students, welcome to Vari Medical Academy. So, உங்களுக்கு எல்லாத்துக்கும் ஒரு குட் நியூஸ். Vari Medical Academy சார்பாக இனி வரும் நாட்கள் டெய்லியும் ஒவ்வொரு டாபிக் நம்மளுடைய ஃபேக்கல்டி மெம்பர்ஸ் லைவ் வீடியோ ஸ்ட்ரீம் உங்களுக்கு கொடுக்க போறாங்க. Wish you all the best my dear future doctors. டாபிக் ஏதாவது வந்து கிளாரிட்டி வேணும் அப்படிங்கிற எந்த கண்டென்ட் ஆனாலும் கமெண்ட்ல தெரியப்படுத்துங்க. அதுக்குண்டான சொல்யூஷன் வாரி மெடிக்கல் அகாடமி சார்பாக கொடுக்க ரெடியா இருக்கும். இந்த மாதிரி வீடியோக்கள் உங்களுக்கு பிடிச்சிருந்தா மறக்காம லைக் பண்ணுங்க, சப்ஸ்கிரைப் பண்ணிக்கோங்க.
Good morning. I am Shyam from Vari Medical Academy. Today we are going to discuss about the gravitation, acceleration due to gravity. In gravitation, particularly acceleration due to gravity. Acceleration due to gravity, small g. Acceleration due to gravity. Acceleration due to gravity is the acceleration gained by the body due to gravitational force of attraction of the earth. That is the acceleration due to gravity. G value is generally it's a constant, but it is changed place to place. Suppose take as earth, at the center of the earth, at two poles of the earth, it will be changed. The value will be changed. Of course, at nearest points it's approximately same, but at here and different altitudes, the value will be changed. A small changes is there, and from the earth to some heights, h height, the value will be g value will be changed. At earth surface to inside the earth, the value will be changed. Okay, we can observe this. Generally, g is a vector quantity. G, small g, acceleration due to gravity is the vector quantity. It is the vector quantity. Its dimensional formula of the G. G dimensional formula is L T power minus 2. Acceleration dimensional formula and acceleration due to gravity dimensional formula both are same. G is equal to L T power minus 2. Its SI units. SI units is meter for second square. Meter for second square. SI units. SI units of the G is meter for second square. This G value is constant. Generally, it is 9.8 meter for second square. Sometimes we are also take G is equal to 10 meter for second square. 10 meter for second square, because it will be variation. There is a variation of G at place to place, just we discussed. At the poles, at center of the earth, the value will be changed. Further, we are discussing about that. So, variation of G with height. Variation of G with height first we will discuss. Acceleration due to gravity. First point is variation of G. Variation of G with height. Height H height or altitude, take as altitude. We know that on the surface of the earth, the G value is on the surface of the earth. Surface of the earth, the G value is on the surface of the earth, G is G is equal to, we can write as Gm by R square. G is equal to Gm by R square. At some height, h height, the G value is, okay, second point, it is on the at h height, the G is h height, the G or acceleration due to gravity is h height, acceleration due to gravity is, what can we write? GH is equal to GM by, GH is equal to GM by R plus H whole square. This is R plus H whole square. Take as, this is the second equation. GH is equal to GM by R plus H whole square. From 1 and 2 equations, we can write as GH by G is equal to, from 1 and 2 equations, GH by G is equal to GM by R plus H whole square whole divided by GM by R square. This is, it will become GM gets cancelled, GM gets cancelled, then GH by G is equal to R square by R plus H whole square. GH by G is equal to R square by R plus H whole square, where R is the radius of the earth, capital M is the mass of the earth, okay, G is the universal gravitational constant. Okay, so from this GH is equal to G into R square by, take as R square is the common, then this is 1 plus H by R whole square. This is whole square, that's why we can write as R square. R square gets cancelled, then GH is equal to G by 1 plus H whole square. This is also write as GH is equal to G into 1 plus H by R whole to the power of minus 2. GH is equal to G into 1 plus H by R whole to the power of minus 2. From binomial theorem, we can expand this 1 plus H by R, and for small values, we can write as G is equal to, GH is equal to G into 1 minus 2H by R. GH is equal to G into 1 minus 2H by R. According to binomial theorem, we can expand this 1 plus H by R whole to the power of minus 2 can be expanded from binomial theorem. So, and also for small h values, R is greater than H, then we can write as GH is equal to G into 1 minus 2H by R. Okay, this is the G value at some height from the earth surface. Suppose take as this is the earth and this is the radius of the earth, or some height means this is this height. Take as this is the height, h height. At this point, GH is equal to G into 1 minus 2H by R. At this point, GH is equal to G into 1 minus 2H by R. And what about this point? At this point, this is the G. G is equal to GM by r square. This is G is equal to Gm by r square. Look at that. If height will be increases, if the height will be increases, the G value is decreases. G value is decreases. If the height is increases, G value is decreases. GH is equal to G into 1 minus H by R, right? Here it is GH. GH is equal to G into 1 minus 2H by R is the general equation, right? So, from this we can say that if height increases from earth surface, G value will be decreases. G value will be decreases, right? This is how much G value is decreases at some height, some H height. How much G is decreases? We can take as from this only. Okay, delta G at some height, at H height, the decrease of G is, the decrease of G is delta G. Take as the decrease of G is delta G. Take as from earth surface to 20 kilometers or 30 kilometers, 20 kilometers, 30 kilometers, there is no change. Take as R by 2 height, otherwise R height, otherwise 2R height, 3R height. At that places, G value will be maximum decreases. That is delta G. Delta G is equal to G minus GH. Delta G is equal to G minus GH. So, delta G is equal to G minus GH is nothing but G into 1 minus 2H by R. Delta G is equal to G minus G into 1 minus 2H by R. So, delta G is equal to, we can write as G minus G minus G plus 2H by R into G. These two gets cancelled. Then delta G is equal to 2H by R into G. Delta G is equal to the decrease in G value at some height 2H by R into G. This is called as the absolute decrease in G value. It is called as absolute decrease. Absolute decrease of G value. Absolute decrease. Absolute decrease of G value. Okay, this is delta G is equal to 2H by R into G. This is called as absolute decrease of G value. Next, fractional decrease of G value. Fractional decrease of G value also we will get easily from this. Absolute decrease is 2H by R into G, and fractional decrease, we are also getting the fractional decrease, that is, look at this, delta G is equal to G minus GH, right? Delta G is equal to G minus GH. Simple, this is called as the absolute decrease of G. Absolute decrease of G. absolute decrease of G. Delta G is equal to G minus GH. That's nothing but 2H by R into G. It's nothing but 2H by R into G. Now we want the fractional decrease. Fractional decrease, that is, next point, delta G by G. Delta G by G is equal to 2H by R. This is called as the fractional G. Fractional decrease of G. Fractional decrease of G with some height. Fractional decrease of G. Fractional decrease of G with increase of height. Increase of height from earth surface. From earth surface. Fractional decrease of G with increase of height from earth surface. Delta G by G is equal to 2H by R. This is also written as R or R. Delta G by G. Delta G by G is equal to G minus GH by G. This is the fractional decrease. Fractional decrease of G with increase of height from earth surface. Final one, absolute decrease, fractional decrease, and also percentage decrease of the G. Percentage decrease of G with increase of height from the earth surface. Okay, last one. This is, look at this, from this delta G by G. Delta G by G is equal to, we have 2H by R. 2H by R. Otherwise, we can also write as delta G by G is equal to G minus GH by G. This is delta G by G into 100 is equal to 2H by R into 100. This is called as the percentage decrease of G with increase of height. This is percentage decrease. Percentage decrease of G with increase of height H. With increase of height from earth surface. From earth surface. This is the fractional percentage decrease. This is also write as, this equation also write as delta G by G. Delta G by G into 100 is equal to, we can write as G minus GH by 100, G minus GH by G into 100. We can write like this also. This is the fraction percentage change of the decrease of G with increase of height. Next, if the from earth surface to inside the earth means if the height will be decreases, depth will be increases, then what will be happen? It is increase or decrease. The G value will be increase or decrease. We can discuss that. Variation of G with depth. Variation of G, small g, with depth. Variation of G with depth. On the earth surface, we know what is the G. On earth surface. On earth surface, acceleration due to gravity is, on earth surface, G is simple. G is equal to Gm by R square. Not only earth surface, on any planet. On planet of planet surface, G is gm by r square. G is equal to gm by r square. Capital G is the universal gravitational constant and m is the mass of that planet and r is the radius of that planet. Here we need to take the earth. We are discussing about the earth gravitational acceleration due to gravity. That's why here G is related to earth G. Earth G value is 9.8. That is the constant. Okay. And G is equal to G, and this is also written as G by r square into mass. We can write as mass of the earth or mass of the planet is 4 by 3 pi r cube rho. Pi r cube rho. 4 by 3 pi r cube rho. It's a sphere. Okay. That is 4 by 3 pi r cube rho. M is equal to V into rho. M is equal to V into rho. M is equal to 4 by 3 pi r cube into rho. This is the mass of the earth. Okay. We can write that G is equal to G by r square into 4 by 3 pi r cube rho. Just to cancel it. Then G is equal to, we get 4 by 3 pi r rho into G. Rho into G. This is the G value on the surface of the earth. Now we can take as this is the earth surface. At the from here to here, this is r value. On the earth surface, G is equal to what we are getting? 4 by 3 pi r cube rho into G. Right? Now, at this point we want, at this point, at this height, at this I height, this is the D, depth. Okay. So, this value is r minus D. This is r minus D. Okay, this is. Here we want GD at depth, at D, the G value D depth, at D depth of D, at a depth of D, G is, we can write as GD is equal to 4 by 3 pi r minus D, take as simple r minus D into rho into G. This is the first equation. This is the second equation. From 1 and 2 equations, G and GD. So, GD by G is equal to 4 pi by 3 into r minus D into rho G by 4 pi by 3 into r rho G. R rho G, 4 pi by 3, 4 pi by 3 gets cancelled. Then we can get as GD is equal to G into r minus D by D. R minus D by D. This is GD is equal to, this is GD by G is equal to 4 pi by 3 RD into rho G divided by 4 pi by 3 R into rho into G. Rho G cancel, 4 pi by 3 gets cancelled, R minus D by R. GD is equal to G into R minus D by R. Oh, here it is R. This is R. So, we can also write as GD is equal to G into 1 minus D by R. This is the final equation. So, from this also we can say that if the depth increases from the earth surface, G value will be decreases. So, we can say that if depth increases from the earth surface, GD also decreases. GD also decreases, right? This is GD at D depth. Okay, now we want the absolute GD. How much G will be decreases from D depth from the earth surface? How much G will be decreases from the earth surface with the depth of D? We can find that. That is also, it's nothing but absolute G or delta G. How much G value is decreases? This is GD is equal to G into 1 minus D by R. We want the absolute GD, absolute G, that is delta G, right? Delta G is equal to G minus GD. Okay, we know this equation. GD is equal to G into 1 minus D by R. So delta G is equal to G minus GD. Delta G is equal to G minus, in the place of GD, we can write as G into 1 minus D by R. This is delta G is equal to G minus G plus D by R into G. G minus G plus D by R into G. These two gets cancelled. Then we can write as delta G is equal to D by R into G. This is the absolute decrease of G with increase of depth. Absolute decrease of G at depth of D from earth surface. Okay, this is the G. Delta G is equal to D by R into G. From this we are also write as absolute G after fractional G. Fractional G also we can write. It is useful in errors. Directly we get the answer here. Delta G by G. Delta G by G is equal to D by R. This is the fractional decrease of G with from earth surface to D depth. Okay, this is fractional decrease of G at D depth from earth surface. Okay, this is fractional decrease of G at D depth from earth surface. Otherwise, this equation also write as delta G by G. Delta G by G is equal to, we can also write as G minus GD. G minus GD by G. G minus GD by G. This is also fractional decrease of G at D depth from earth surface. Finally, one more point. Percentage decrease of G at D depth from the earth surface. We can write as that is delta G by G into 100 is equal to G minus GD by G into 100. This is okay. Delta G by G into 100 is equal to G minus GD by G into 100. This is the percentage decrease of G. Percentage decrease of G at D depth from Earth surface. Percentage decrease of G, percentage decrease of acceleration due to gravity at D depth, depth from Earth surface. This is this is the absolute decrease, it's a fractional decrease, and this is the percentage decrease. And at D depth, the value of G is GD is equal to G into 1 minus D by R. Yeah, look at this. At the same height of Earth surface to some height and Earth surface to some depth, same values. In which place the G value is more decreases, we will discuss in the next video. Thank you.